and I'm going to take you through section 1 of this paper 2. So in this section we are required to answer all the questions in the spaces provided. That is for this section 1. So we are going to begin with the first question, and the first question is actually tested on the topic on sequence and series. Sequence and series. That is a Form 3 topic. So an arithmetic progression AP is given as 600, 650, 700, 750. Determine part A of the question, the 30th term of the AP, which is 2 marks. Then part B, the sum of the first 30 terms of the AP. So since this is an AP, to get the nth term of an AP is given by the first term A plus n minus 1 into bracket, then multiplied by the common difference. So for our case here, the first term A is 600. Then the common difference we get by multiplying second term, by subtracting second term, the first term, or third term with the second term, fourth term with the third term, and so on. So for our case D, the common difference, 650 minus 600, we get as that is 50. So there's a difference of 50 in each of these terms, the first, second, third, fourth, and so on. Therefore, and n, the 30th term. So the 30th term will be t sub 30. A is 600, then plus n is 30, so that will be 30 minus 1, then multiply by the common difference, 50. So this will be 600 plus 30 minus 1, that is 29, then 21, 9 times 50. So we end up getting 600 plus 29 times 50, we get, that is 1450. So we add 600, we end up getting 2050. So this is the 30th term of this progression. Then part B of the question, the sum of the first 30 terms of the AP. The sum of n terms of an AP is given by n over 2, open the bracket, we have A plus the last term, L. Or the other way we could do it is the sum of n term is given by n over 2, open the bracket, 2a plus, to bracket n minus 1, close the bracket, multiply by d, close the bracket again. So we can either choose of this method, either of the method. But if we check on part A, since we want to find part B, sum of the first 30 terms of the AP, that means the 30th term of this AP is the last term. So we can be able to use this formula. So sum of the first 30 terms be given by n over 2, n is 30, 30 over 2, then open the bracket, we have A is 600, then plus last term we have found it in the first part of this question, that is 2050, then close the bracket. 30 over 2, that is 15, the bracket. 600 plus 2050 plus we get 2650. So if you multiply it times 15, so we get 39,750. We proceed to question number 2. The quadratic equation 5x squared plus kx plus 20 is equal to 0 has only one root. Determine the possible values of k. So how are we going to determine the possible values of k? So for this case, these are actually a repeated root. It's a repeated root, and therefore, for repeated roots, it has the same solution, the value of x. Therefore, in this case, the discriminant, which is normally b squared minus 4ac, will be equal to 0. That's the discriminant. And for our case here, since this equation given 5x squared plus kx plus 20 is of the form ax squared plus bx plus c is equal to 0. Therefore, it means that we compare the coefficient of x squared, the coefficient of x, and also the constant term. So the coefficient of x squared, a, will be equal to 5. The coefficient of x, b, is equal to k. And the constant term, c, is equal to 20. Therefore, using the discriminant, b squared minus 4ac is equal to 0. Now, this will be the same as b squared is equal to 4ac. Now, we can be able to get the value of k. So, in this case, b is equal to k, so we have k squared is equal to 4 times a is 5 times c is 20. So k squared is equal to 4 times 5, that is 20, times 20, that is 400. Therefore, to get k, it is the square root plus or minus the square root of 400. And the square root of 400 is 20. Therefore, k is either minus 20 or positive 20. And that is the value of k. So our question number 3 is, without using mathematical tables or a calculator, evaluate. We have logarithm of 125 plus logarithm of 64 all over logarithm of 6th root of 5 plus the logarithm of cube root of 2. First, we need to write 125, 64 and the others in terms of prime factor form. So 125 can actually be written as 5 raised to 3. The same case also applies to 64, can also be written as 2 raised to power 6. It can be written as 2 raised to power 6. And therefore, let us rewrite this again. Logarithm of 125 is the same as log of 5 raised to 3 plus logarithm of 64 is the same as logarithm of 2 raised to 6 all over, the other one can be written as logarithm of 5 raised to a sixth, plus logarithm of cube root of 2 can be written as logarithm of 2 raised to a third. Therefore, we are going to apply the laws of logarithm, whereby if you have a logarithm, log of a number a raised to power n can be written as n log a. And therefore, in our case here, we shall have, this can be written as 3 log of 5 plus, this will be 6 log of 2 all over, here we have a sixth log of 5 plus, this can be written as a third log of 2. Therefore, checking the numerator, we can factor out what is common. We can see here 3 and 6. 3 is common to both. So we have 3. We can factor out 3. So we have 3. Open the bracket. So we have log of 5 plus 6 log 2 divided by 3. We get 2 log 2. Close the bracket. All over. The denominator, we have a sixth and a third. So a sixth is common to both. Since a sixth is smaller than a third, a sixth will be smaller. Common. So a sixth, open the bracket. A sixth log of 5 divided by a sixth, get log 5. Then plus a third log 2 divided by a sixth, we get 2 log 2. Close the bracket. So, if you look keenly at this, we can see that the numerator part, whatever we have in bracket log 5 plus 2 log 2, also in the denominator we have log 5 plus 2 log 2. So this will cancel out, and therefore we end up having 3 divided by a sixth, which is the same as 3 times the reciprocal 6 over 1. So we end up getting 3 times 6, which is 18. So that's question number 3. And this question number 3 is from 3 work, topic on further logarithms. So we proceed to question number 4. Make x the subject of the formula. Make x the subject of the formula. So we have y is equal to a over b raised to x. Make x the subject of the formula. So we can multiply both sides by b raised to x multiplied by b raised to x. So this will cancel out. Therefore, we have b raised to x times y is equal to a. Then again, we divide both sides by y divided by y. So y and y will cancel. So we have b raised to x is equals to a over y. So we need to take logarithm on both sides. Take logarithm on both sides. Since here we have an exponential value, so this will be log of b raised to x is equal to log of a over y. So Using the laws of logarithm, we have a logarithm of a number a raised to n can be written as n log a. Therefore, this can be written as x log b is equal to log of a over y. So divide both sides by log b. Divide both sides by log b. So this will cancel out. And therefore, we have x is equal to log of a over y all over log of b. You can leave this answer like that, or applying the laws of logarithm whereby log of a number a over b could also be written as log of a minus log of b. And therefore, this can also be written as x is equal to, now applying this law of logarithm to the numerator part, that will be log of a minus log of y all over log of b. So you can either give one of these answers. So let us proceed on. Next is question 5. And in question 5 says the unshaded region on the Cartesian plane satisfy the inequalities. Satisfy these inequalities. X plus 3y is less or equal to 21. Minus 3x plus y is less than minus 3. Minus 3x plus y is greater or equal to minus 13. And x plus 3y is greater or equal to 11. So here we have the inequality. This region represented by the inequalities, the unshaded region. And therefore, the question is find the maximum value of x plus 4y for the integral coordinates p, x, y lying in the unshaded region. So we need to find the integral coordinates p, whereby it lies in the unshaded region, whereby it will give a maximum value x plus 4y. So in this case, you have to note that 4 plus xy give, this is referred to as the objective function. Objective function, whereby it should give a maximum value. If you get for the value of x and y, it should give a maximum value. And therefore, we are going to say let x plus 4y equal to, say, a value 6, in our case 6, such that we should be able to draw a such line. So we are going to use this to draw a such line, and the such line we are going to draw will help us to draw objective function whereby it will be at a particular point, whereby it will give a maximum point. And therefore, if we look inside this point, we produce a line to the search line. At the last, a reasonable point, a plausible point, say this particular point here, whereby the value of x is 6 and the value of y is 5. We have that a plausible or a reasonable point such that will give a maximum value. And therefore, we need to draw the search line, this search line. So we just require at least 2 points. And therefore, we need at least 2 points. When x is 0, in this case, what will be the value of y? When x is 0 here, in this case, x is 0, so we have 4y is equals to 6. Therefore, y is 6 over 4, which is 1.5. So it will be 1.5. Again, what about when y is 0? So that we can be able to draw that such line easily. So, in this case here, when y is 0, substitute here 4 times 0, so x is 6. So we are going to plot this particular point and draw the such line. So that will be, so we have x is 0, y will be 1.5 at that particular point, and then when x is 6, y is 0, that particular point. So take the ruler and we join these 2 points. So we have, this is our search line, that is x plus 4y is equal to 6. Therefore, we use this search line to draw another line. So using a set square, so I have a set square there and that ruler, and therefore I will use this set square. So at this point, so I want you to learn on how to use the set square. So using this edge, place the set square on that such line, such that its edge be on that line. Then take the ruler, place on the other side, and then we slide the set square along this, such that it will reach to this plausible point we had chosen at this point here. So such that we draw a parallel line to the search line. So let me just slide it. So that is there. You have that point. So let me remove the ruler, then leaving the set square at its place and draw that parallel line. So I've drawn that parallel line to the search line. So that means any point along that line, the line you have drawn, will give a maximum value. But we need an integral value. For an integral value, it should be a whole number, 1, 2, 3, 4, 5, 6, 7, and so on. It should not be a decimal. And therefore, for our case, x plus 4y is equal to, say, k, whereby k will give the maximum value. So under this point here, we have 6, 5. So x is, we have point P, which now is 6, 5. Using it, get x is 6 plus 4 times y is 5. So this is 6 plus 20, and therefore it will give us a maximum value of 26. So the other way to go about it, and this you can do it just manually, just looking at the points inside the unshaded part. We take integral points. So we have this point here. We have this point here, whereby x is 3, y is, we have 3, 5. We have also this point here, integral point, whereby x is 4, y is 5. So we have 4, 5. We have this point here also, which is x is 5, y is 5. So we have that point. And this point here, which we have 6, 5. Then we move on. We can have this point here, which is 3, 4. We have this point also here, which is 4, 4. We have the other point, which is 5, 4. We have this point, which is 3, 3. Also, another point that we have this point here also, which is 4, 3. And also the other point, which is 5, 5, 3. We have also this point here. Since this line is complete, so also this point is included, and that is 5, 2. But among all these points, if we substitute into our objective function, it must give a maximum value. And here is the case. If you work it out, you substitute the way I have done this, the value get this one, you'll get a value of 23. The other one will get a value of 24. The other one will get a value of 25. This will get 26. For this you substitute, you will get 19. The other one you substitute, you will get 20. The other one you will get 21. For this one you will get 15. This value substitute into the objective function, you will get 16. The other one will get 17. And the last one, you will get, that will be 6 plus 8, you get 14. But we can be able to see that this is the one which gives a maximum value. So you can either use this method, draw the search line and find the objective function, the maximum value, or the optimization, or use the other method also. So we move on to our next question, number 6. So we have question number 6. Question 6. An aircraft flew due west from point A, which is 39.64 degrees north, 50 degrees east, to a point B, that is 39.64 degrees north, 20 degrees west. Calculate the distance covered by the aircraft, correct to the nearest kilometer. Correct to the nearest kilometer. So we take pi to be 22/7 and r to be, r is the radius of the earth, which is 6,370 kilometers. So allow me to make a sketch. Globe. We have the equator, 0 degrees. And point A and B, they are on latitude towards north, at the same latitude, which is 39.64 degrees north. That is the latitude for both point A and B. Point A is to the east, while point B is to the west. So they are in the opposite side of the prime meridian. So we have point A, so this is 50 degrees east, point A, and point B, which is 20 degrees west. So if we draw the small circle at this point, we need to find the distance covered along the latitude AB is given by the longitude difference over 360 times 2 pi r, the radius for the small circle, since this is a small circle, is given by r cosine alpha. In our case here, theta is the longitude difference. Since they are on opposite side of the prime meridian, so we add the longitudes 20 plus 50, which is 70 degrees. Then our latitude difference alpha from the equator, it is 39.64 degrees. And we have been given r, which is 6370. So we substitute and get the arc, the distance covered by the aircraft. So that is the arc AB. So it will be theta is 70 degrees all over 360 times 2 times 22 over 7 times r is 6370 times cosine alpha, and that angle is 39.64 degrees. So we can work it out and see what we are going to get. So 70 over 360 times 2 times 22 over 7 times 6370. So this gives us 7,785.56, then times cosine of 39.64 is 0.7701 for significant figure. So we end up multiplying them. So we shall get so this 7701. So we end up getting 5,995.659756, but the question requires to the nearest kilometer. Therefore, this will be 5,996 approximately. So that is the distance AB. So we shall move on to our next question. Our next question, 7. In the following figure, ABCD, we have ABCDE are points on the circumference of a circle. Line AB is parallel to line BC, and line FAG is tangent to the circle, at point A. Angle GAB is 25 degrees and angle ABC is 100 degrees. So the question requires us to determine the size of angle BAC, angle BAC. So we require to find out this angle. Let me call it Y. And the other angle, angle AED, this angle here. Let me call it X. Fine. So we need to find that angle and the other one. So for this case here, we've been given that information, and since that information will be very important to us, so at this, the tangent, we have this tangent, and we have this chord AB. We have the chord AB. The angle of 25 degrees is subtended by the chord AB and the tangent. So this chord, we have this segment here. This is the segment we have here. And we have the other segment. And therefore, we are going to use the tangent theorem, which says that angle subtended by a chord and a tangent is equal to the angle subtended by the same chord. The angle subtended by this chord in the opposite segment, alternating segment. This is the angle subtended by this chord AB. It is equal. It is equal. So the angle subtended by a chord and a tangent in the opposite alternate segment, it is equal. So this will be 25 degrees. That will be 25 degrees. Therefore, we can now be able to get angle Y. So since the triangle ABC, the sum of angles add up to 180, therefore we can get, so that means Y plus 100 plus 25 will give us 180. Therefore Y will be 180 minus 100 plus 25. So this 125. 180 minus 125, we get 55 degrees. So this angle Y is 55 degrees. So this is 55 degrees. Therefore, we move to part B of the question. We need to get angle AED, this angle here. And therefore, we need to consider this cyclic quadrilateral. So this figure touches the circle at 4 points on the circumference. So it is a cyclic quadrilateral. ACDE. So that's a cyclic quadrilateral. And you know that opposite angle are supplementary. That means they add up to 180 degrees. They add up to 180 degrees. And since this angle here is 55 degrees, line AB and DC are parallel to each other. That means, allow me to draw this point. We have D, line DC, and line AB. They are parallel to each other. And there is this line AC. We have the line AC. So at this point, this is 55 degrees. It will be alternate to this angle, which is 55 degrees. Since AC is a transversal line, therefore, this angle here is 55 degrees. And we have said the opposite angle of a cyclic quadrilateral are supplementary. Therefore, it means that X plus 55 will add up to 180 degrees. So X will be equal to 180 minus 55 degrees. And therefore, we end up getting 125 degrees. Therefore, angle AED is 125 degrees. So this angle is 125 degrees. So we are going to proceed to our next question. Question number 8. Triangle ABC with vertices A, which is 1, 0, point B, 3, 0, and point C, 1, 2, is transformed by the matrix T, whereby this is 3K, 1.6, 3K minus 0.9, onto triangle A prime, B prime, C prime. Given that the area of triangle A prime, B prime, C prime is 6 square units, determine the value of K. So this question comes from the topic of matrices and transformation. So from 4 question topic, and it is testing on the area scale factor, you need to know that, and also the determinant of a matrix. Therefore, area scale factor is given by the area of image. We divide by area of object. But for our case, we have been given the area of the image, which is 6 square units. We have been given the points of the object, and also we have been given the transformation matrix. First, we need to find the value of K. Something else we need also to find is the area of the object. And we know that area scale factor will be given by the determinant of the matrix, transformation, matrix T. So if we get the determinant of this matrix, then we'll be in a good position to get the value of K. And therefore, we can start by getting since we already have the area of the image, which is 6 square units, we can get the area of object, and that is a triangle ABC. So we can be able to see point A and B, they are on the same axis, y-axis. And you can see the y coordinates is the same, and therefore we have point A, which is 1. Then we advance to the right, B, which is 3, 0. And point C, the x coordinate is 1. That means it will be in line with A, perpendicularly upwards. So we have point C, which is 1, 2, and therefore let us join 2. So from A to C, since there is a change in the y coordinate, so it is 0 to 2, that is 2 units. And then A to B, there is a change in the x coordinate from 1 to 3, so the difference is 2 units. So we can get the area of ABC, that is the object, which is a half base times height. So that's a half, base is 2 units, times height is 2 units. So by 2 1 by 2 1, so we get 2 square units, 2 square units. And therefore, we can get now the area scale factor, which is given by the area of the image, and we provided with the area of the image, which is 6, over now the area of the object, which is 2. So we end up getting 3. So area scale factor is equal to 3. Also, we can get the now determinant of the matrix. We can get the matrix 6k, 1.6, 3k, negative 0.9. So multiply the elements in the main diagonal, 3k times minus 0.9, then minus the other diagonal, subtract we multiply the element in the other diagonal, 3k times 1.6. So this would be 3k times negative 0.9. We get negative 2.7k. The other one is 3k minus 1.6. So we get minus 4.8k. So if we subtract them, we get minus 7.5k. Now we know that area scale factor is equal to the determinant of the transformation matrix T. So area scale factor is 3, and the transformation determinant of the transformation matrix is minus 7.5k. So k will be equal to 3 over minus 7.5. If we simplify this, we get minus 1 over, it will be 4, or minus 0.25. So k is negative a quarter or minus 0.25. So that is the value of k. We move on to question number 9. Question number 9. Solve the equation 6 cosine x squared plus sine x is equal to 4 for 0 degrees is less or equal to x is less or equal to 180 degrees. So we have been given that range. So one thing we need to note that this question is tested on Trigonometric from Trigonometric 3, a topic in Form 4, and therefore one thing we need to remember is the trigonometric identities, whereby cosine x squared plus sine x squared is equal to 1. So this can be written as cosine x squared is equal to 1 minus sine x squared. So we can substitute this into the given trigonometric equation. And if we do so, where we have the cosine x squared, we substitute with 1 minus sine x squared. So that will be 6 to bracket 1 minus sine x squared, close the bracket, plus sine x is equal to 4. So for this, open the bracket, we have 6 minus 6 sine x squared plus sine x is equal to 4. So we can rearrange it such that we have minus, we have 6 minus 6 sine x squared plus sine x minus 4 is equal to 0. So 6 minus 4, we have 2. Then minus 6 sine squared plus sine x is equals to 0. We can rearrange it such that we have 6 sine squared minus sine x minus 2 will be equal to 0. Now we have formed a quadratic equation. This is actually a quadratic equation, and therefore we can say let sin x equal to, say, a value a. Therefore, substitute sin x with a. So here we have 6a squared minus a minus 2 is equal to 0. So we are going to solve this quadratic equation. So let us solve the quadratic equation. So we have the product using factorization method. Find the product. AC is given by, this will be 6a squared times minus 2, that is minus 12a squared. Then we get factors of minus 12a squared such that the two factors we get, when we add them, we get minus a. So we shall have minus 4a and 3a. Remember, when we multiply the two, we must be able to get minus 12a squared. If we add the two, we get minus a. So we write now this quadratic equation, the middle part in the expanded form, that will be 6a squared minus 4a plus 3a minus 2 is equal to 0. So let us now take into pairs and factor out. So 6a squared minus 4a, 2 is common in 6 and 4, and also a is common. So 2a, we are going to factor it out. So 3a squared divided by 2a, get 3a, minus 4a divided by 2a, get 2. The bracket, then plus 3a minus 2, 1 is common. So factor out 3a divided by 1, get 3a. Minus 2 divided by positive 1, we get minus 2. Close the bracket, will be equal to 0. So take this, which will be 2a plus 1. Then pick the one that we factored out. So we have 3a minus 2 will be equal to 0. That simply means either 2a plus 1 is equal to 0 or 3a minus 2 is equals to 0. Therefore here a will give us minus a half, or here a will give us 2/3. But from the given range, we know that we said let sin x be a. That means sin x is equals to minus a half, or sin x is equal to 2/3. But from the given range, one thing I want you to note that is that from the first quadrant to the fourth quadrant, 0, 90, 180, 270, back to 360, sine is positive. So we need the range from 0 to 180 only. That means we base ourselves with angle from the first quadrant and the second quadrant for the sine. Sine, in this range, the angle is positive. So we are going to ignore sine x is equal to minus a half, and we take sine x is 2/3. So if we do that, therefore x will be sine inverse of 2/3. So x we get, so if we work it out, sine inverse of 2/3 that is 41.81 degrees. So this is the acute angle in the first quadrant. Acute angle in the first quadrant. So in the second quadrant also, we need the whole of these angles. So in the second quadrant, the acute angle will be the same, and therefore it will be 180 minus 41.81. So in the second quadrant, the angle is 138 degrees, 138.19 degrees. And that is the value of x, and that is correct to 2 decimal place as the question has instructed. So we move on to our next question, and that is question number 10. So question number 10, the figure below shows a circle. This is the circle. Line CP and CQ are tangents to the circle at point P and Q respectively. So the circle is inscribed in a triangle ABC. Point B lies on OCQ produced, and angle CBA is 90 degrees. We use a ruler and a pair of compasses only to locate point O and the center of the circle. Then we complete triangle ABC. So since the information given is that CP is tangent to the circle at point P and CQ is tangent to the circle at point Q. Another property that we need to know is that if we draw a perpendicular through this point here, it will pass through the center of the circle. That means the radius, we draw from here to the center, the radius is perpendicular to the tangent. So we can easily be able to draw the radius from this point to the circle, and therefore we take a compass. So I'll place compass at point Q, and then let me adjust. So I put a mark there, and also on the other side put a mark. Then I'll use the arc as the center. Then adjust the radius. So put an arc above and also below. I do the same with the other side, maintaining the radius of the compass. Put an arc above, the same case below, and then take a ruler and draw that line. So I can draw the line. Then I do the same with the other point. From point P, I do the same thing. Draw an arc on this side and also on the other side. Then using those arcs as the radius, adjust. I'm going to draw an arc on this side, and also I'll do it on the same side. So I do it on the other side, maintaining that radius. Again, on this side, I use this arc as the center. Put that arc. Also, I do the same with the other side. I put an arc there, and then I will join. So now I have this point as the center of the circle. So this is our center of the circle, point O. So that's our center of the circle. So something else that we need to note, that from this point here, QO, that means OQ will be equal to QB, because we have been told that B is produced, lies on the CQ produced. So, and it is that side AB also touches this circle at this point. So it's actually a tangent to the circle at this point, since the circle was inscribed. So that distance OQ, so using the compass, can put that mark. Change the color back. Say, so that point be the same. So point B lies there. So that will be our point B. So at B, it is perpendicular. It is perpendicular. And therefore, at B, we are going to draw a perpendicular at P. That's at B, I mean, at B. So at point B, put an arc there. The same case, I'll also do the other side. Fine. Then using we adjust the radius using the arcs, and we adjust radius less than this, such that we are going to put an arc there, and also use the other side as the center. That. So fine. Therefore, we are going to draw line. So at that point, so draw a line there. Fine. So I'll be required to extend this. So we extend that line. So we have point A, and that is it. So now you have located point A, and also you have completed triangle ABC. So that is it, and that's how you're supposed to have drawn it. So next we have question number 11, and this is a statistics question, statistics 2 for work. The deviation of the masses of 10 students from an assumed mean are -10, -5, -2, 1, 4, 5, 7, 8, 9, and 13. The mass of the heaviest student was 58 kilograms. Calculate the mean mass of the students. The mean mass of the students. And instruction we have been given, we use an assumed mean. Therefore, say let the assumed mean. Let the assumed mean be A. Let it be A. That means we have this the deviation from the masses of the student. That means we have been given the heaviest student is 58. If you look at the deviation of the masses for the 10 student, that means the one with a deviation of 13 is the heaviest student, and therefore the mass of the heaviest student minus the mean, that mean we have to find is equal to 13. Therefore, A will be 58 minus 13, and A is 45. A is 45, that is the assumed mean. And since we have been given the deviations, we are going to apply the assumed mean formula, and for us to get the mean, it's given by the assumed mean plus summation of FD over summation of F, whereby F is the total number of the students, which is 10. Therefore, deviation we have -10, we have -5, -2, we have 1, 4, 5, 7, 8, 9, and finally we have 13. That means the frequency for each is 1, 1, 1, 1, 1, 1, 1, 1, 1, all the way. Therefore, we can get FD minus 10 times 1. So we do that throughout. So we shall get -10. It should be -5, -2 times 1, that is -2. Then 1, 4, we have 5, it should be 7, 8, 9, 13. So for this case, we need to get summation of FD. So summation of FD will be given by, so we had this all through, and if we add, we get -10, -5, -2, +1, +4, +5, +7, +8, +9, +13. So we get it is 30. So we have 30. Summation of FD is 30. Summation of F is 10, the number of students. Therefore, the mean, we get the mean mass is given by the assumed mean, which is A is 45, plus summation of FD, the sum of FD we get is 30, divided by sum of the students, which is 10. So this will be 45 plus 30 divided by 10 is 3. So 45 plus 3 is 48, and that is 48 kilograms. So that is the mean of the students. We are going to proceed on question number 12. Question number 12. Question number 12 is about commercial arithmetic, that is taxable income, commercial arithmetic. So the following table shows part of a monthly income tax rate for a certain year. The monthly taxable income in Kenyan shillings, and also we have the tax rate percent in terms of percent. Then the first band is 0 to 11,180. It is taxed at the rate of 10%. Then 11,181 all the way to 21,714. It is taxed at 15%. And then 21,715 to 32,248 is taxed at the rate of 20%. So in a certain month, an employee paid a net tax of 2,200 Kenyan shillings after getting a tax relief of 1,280 shillings. So calculate the employee's taxable income in that month. So remember, we use this the tax rate table to find the taxable or the tax due toward the end of the month. And therefore, you know that tax due is given by the net tax plus the relief. That means to get the net tax is actually with the tax due minus the personal tax relief. And here we have been given the net tax, and also we have been given the tax relief. Therefore, the tax due in that particular month was 2,200 plus the tax relief, which is 1,280. If we add the two, we get 3,480. That means this was the tax due in that particular month. And therefore, let us use this table now to calculate the tax due for each band. We have the first band, the second band, and the third band. So the first band, or the first bracket, or the first slab, what was the tax due? So to a maximum of 11,180 times the rate 10%. So we shall end up getting, so that is 11,180 times 10%. We get 1,118. For the second band, now we have what will be the excess of 11,180? So we take 21,714 minus this amount, 11,180, and if we do so, 21,714 minus 11,180, we get 10,534 times the rate in the second band is 15%. So if we work it out, times 15%, we get 1,580 and 10 cents. Then the third band. So one thing we need to note, since we want to get the taxable income, we say let the taxable income be X. Let it be X. Let it be X. And therefore, we need to add the sum of this 11,180 because the last band is the third one. And presumably, the income did not reach to this point. That means the monthly basic salary did not reach up to 32. So it reached to a certain amount. And whereby, in our case, the total was 3480. So we need to get the difference. We need to get the difference such that there is a tax, such that we know the tax due in the third band was what. So we have 1,118 plus 1580.1. So then we less 3480. So already when we add the two, we get 2698.10. So we are going to less the total tax due, 3480 minus 2698.1. So that means in the third band, the tax due was 781.90. So again, if we add the two here, that is, let the total taxable income. So the extra amount is X minus these two values. So that is 11,180 plus 10,534. So which is 21,714. Again, at the third band, the tax rate was times 20%. So now we find the value of X. So X minus 21,714 times 20 over 100 is equal to 781.90. So this will be X minus 21,714 equal to, multiply both sides by 100. So 781.90 times 100. Again we divide by 20. So if we work it out, so work this out, 781.9 times 100, then divide by 20. So we get 3,909.50 cents. Therefore, X will be equal to 3,909.50 cents plus 21,714. So the total value, which is the taxable income, with this value plus 21,714. So we get 25,623 and 50 cents. So that was the taxable income in that particular month. So we move on. Question 13. The equation of a circle is given by x squared plus y squared minus 3x plus 4y is equal to 0. Determine the coordinates of the center of the circle and the area of the circle in terms of pi. So, we need to begin by looking at the first, and we have the general equation of a circle. General equation of a circle is given by x minus a into bracket squared plus y minus b to bracket squared is equal to r squared. So let us expand this using the quadratic identities. A minus b squared is a squared minus 2ab plus b squared. So let us expand each. So this will be x squared, then minus 2ax plus a squared using that identity. Then the next one plus square this will be y squared minus 2by plus b squared is equal to r squared. So we can rearrange it such that we have x squared, then plus y squared, then minus 2ax, then minus 2by, then plus a squared, then plus b squared, then take r squared to the left hand side will be minus r squared is equal to 0. So, comparing with the given equation, which is x squared plus y squared minus 3x plus 4y is equal to 0. So compare x squared, y squared, then this is actually x, this is minus 3x. So coefficient of x here, so you have minus 2a is equal to minus 3. So this implies that a is equal to minus 3 over 2 minus 2. So we get 1.5. Compare the corresponding coefficient of y and y. Minus 2b is equal to minus 2, b is equal to 4, and therefore b will be 4 over minus 2, which will get minus, this will be minus 2. Therefore, the center of the circle, we need to get the coordinates of the center. AB is A is 1.5 and B is minus 2. So that is the center of the circle. Then we need to find the area of the circle in terms of pi, knowing that area of the circle is given by pi r squared. But we don't have to substitute pi since we have to leave it in terms of pi. So r squared still under this equation and the given equation, let us compare this particular part. So here this plus 0. So that means a squared plus b squared minus r squared is equal to 0. So this is r squared will be equal to a squared plus b squared. But we know a is 1.5, so we have 1.5 squared plus b is minus 2, so minus 2 squared. 1.5 squared is 2.25 and minus 2 squared is 4. If we add, we get 6.25. But the question requires us to find the area, and our case here r squared is 6.25. So even I don't need to find the square root of this value. So area, which is pi times r squared, is 6.25. So this is 6.25 pi square units. And that is the area of the circle. We move on to the next question. Which is question number 14. And for the question number 14, the position vectors of point A, B, and C are such that OA is equal to 3i minus 5j minus 4k. OB vector is equal to j plus 8k vector, and OC vector is equal to minus 2i vector plus 5j vector plus 16k vector. Show that the points A, B, and C are collinear. For us to show that the points are collinear, first we need to find whether they are parallel to each other, and at least one point is common, both of them. So since we're saying that we need to find whether they are collinear, we have A, B, and C. And also you have been given their position vector. Remember, position vector is say from a point O. So are those point A, B, C collinear? Are they parallel to each other? Is there any point which is common? So we can say let AB vector, so AB vector to be equal to a ratio of k of AC vector. AB to have a certain ratio which divided the lines. So if that is the case, I've taken A will be my common point, and let us use whatever we have been given. So we start with AB vector, since we have been given the position vector, so we start with B, OB vector minus OA vector. So since these are three-dimensional vector, that means there is I, J, and K. For the first one, OA, we have 3. Now we have OB, I is 0, J is 1, K is 8. Then minus OA, I is 3, J is 5, and K minus 4, that's the coefficient, is equal to 0 minus 3, we have minus 3, 1 minus 4, minus 5, we have minus 4, then 8 minus 4, so plus, so you have 12. Then the other one is AC. We have AC vector. So the position vector of C, OC, minus the position vector of E. OC, coefficient of I is -2, since these are three-dimensional vector, -2. You have 5, then 16. Then minus OA. OA is, we have 3, then -5, -5, then we have -4. So in our case here, in our first case here, we made a mistake. So there was -5, so this is -5. So 1 minus -5, so that should be +6. Positive, it's +6. Sorry for that correction. So that's -3, 6, 12. So the other one will be now -2 minus 3. So you get -5. 5 minus -5. So that will be 10. Then 16 minus -4. So 16 plus 4, that is 20. Now we need, since we said AB, let AB vector be equal to K of AC vector. Now we have AB, which is -3, 6, 12, is equal to K. AC vector is -5, 10, 20. So let us see whether there is something common here which can actually be divided. So in the first case here, we can see that we have 3, 6, 12. 3 is common to the 3 elements, so we can factor out 3. Therefore we have -3 divided by 3, so +1. 6 divided by 3, we have 2. 12 divided by 3, we have, that is 4. Will be equal to K times, again, -5, 10, 20. One thing is common, 5 is common to all, so we have 5. So -5 divided by 5, -1. 10 divided by 5, we have 2. And 20 divided by 5 is 4. That means whatever is inside the bracket is the same, and therefore it will cancel out. Therefore, we shall have 3 is equal to K times 5. And therefore, divide both sides by 5. So K is equal to 3/5. That simply means now AB vector is equal to 3/5 of AC. And that means AB is parallel to AC, whereby A is common point. And therefore, we prove that A, B, and C are collinear. Next is question number 15. For question number 15, that's a particle starts from point O and moves in a straight line so that its velocity v meters per second after time t seconds is given by v is equal to 9t squared minus 18t plus 10. Calculate the distance traveled by the particle between the time t is equal to 1 second and t is equal to 2 seconds. So we need to find the distance, but we have been given velocity. That means since we have been given velocity, for us to get the distance, we get back and we do the integration of velocity. So we are going to integrate velocity with respect to time. For us to get distance s, integrate velocity with respect to time, and that's from the lower value t is equal to 1 to the upper value t is equal to 2. And therefore, integrate from 1 to 2, we have v is 9t squared minus 18t plus 10 with respect to time. So we integrate. If we are going to integrate, we add the power of t by 1 and we divide by the new power. So this will be 9t raised to 2. We add 1. We divide by the new power. 2 plus 1 will be 3. Then plus 18t raised to 1. So we add 1, divide by the new power. 1 plus 1 is 2. Again plus 10. In this case, t is raised to 0. Any number raised to 0 is 1. So plus 1 all over the new power, which is 1. Straight from 1 to 2. So we work this out. 9 divided by 3, that is 3t raised to 3, plus 18 divided by 2, that is 9t, 1 plus 1, t raised to 2, then plus, we have 10 raised to t, to bracket 1 the way to 2. Therefore, we get the sum of the upper limit when t is 2. We have 3 multiplied by 2 cubed plus 9. T is 2, so 2 squared plus 10. T is 2. 1. So this is 3 times 2 cubed. This is 24 plus 9 times 4, 36 plus 20. If you work out this, you should get this value was here, it was minus, it is minus, it is minus, so minus 24 minus 36 plus 20, so we are going to get 8. Then lower limit values, again when t is 1, so it is 3 times 1 cubed minus 9, 1 squared plus 10 times 1, so this is 3 minus 9 plus 10. So here we end up getting 4. So finally is the value of the upper limit, which is 8, minus value of the lower limit. So we end up getting 4, that will be 4 meters. Finally, we end up with the last question in section A. Last question in section A. The following table shows the number of units U of water consumed by 6 households in a month. The corresponding amount A charge is also given. So we have the number of units, those are the values given, and the amount charged in Kenyan shillings. So 0.8 correspond to 200, and the rest the same way. So we are supposed to, using the scale 2 centimeter to represent 1 unit on the x-axis and 1 centimeter to represent 100 shillings on the y-axis. Draw the line of best fit for the data on the grid provided. So the instructions are very clear. For the x-axis, 2 centimeter to represent 1 unit. And therefore, from this point 0, we have the axis drawn for us. So from 0 towards the right, that's for the x-axis. So 2 centimeter represent 1 unit. From here to here is 1 centimeter. So interval of 2 centimeter, 2 centimeter, 2 centimeter. So from here it's 1. Then we have 2, 3, 4, 5. Intervals of 1 unit every 2 centimeter. Then for the y-axis, 1 centimeter represent 100. So 1 centimeter, 100. So each 1 centimeter going upwards. So you have 100, 200, intervals of 100, then 300, 400, 500, 600, 700, and 800 and 900. We can reach up to that point since the maximum value is 720. Therefore, we need to plot, but let us also label the axis. So the x-axis represents the number of units, U, and the y-axis represents amount charged, amount A, which is charged. Now let us plot the points, but before we plot the points, it's very important to note one of the following things, is that x-axis from 0 to 1, there are 10 small divisions. That means one small square represent, that will be 1 divided by 10, which is 0.1. For the y-axis also, we know that 1 centimeter represent 100. And from 0 to 100, there are 5 small divisions. That means 1 small square represent, that will be 100 divided by 5 divisions, which is 20. So that is very important as we are going to plot the points. Now, when x is, that's the number of unit, is 0.8, so it's at this point here, and therefore we count from 0, 8 small division, so 0.8 is at that particular point, and then we have 200, is here 200, so that's the point. Next, 1.7 correspond to 340, and therefore 1.7 here we have 1.5, 1.6, 1.7, so at this point, and 340, so one small division is 20. So 300, 320, 340 is at that point. So we move horizontally. So, and here we move upwards. So it will be at this particular point. Then we are done with that. We're done with that. So when x is 2.2, we have 2.1, 2.2. So take care of the one small square. So 2.2 is there. And then 380, it less 20 to reach 400. So 380 is at that point. So we move horizontally up to this point where we have 2.2. So they meet at that point. Then done with it. 2.9. So I have 2.9 at this point here. Then for 80, it is lessing 20 to reach 500. So it is at this point here, horizontally to that point, and this will move vertically upwards. So that's the point. We're done with this. Then 3.5 is at this point, midway between 3 and 4. 600 is point there. So here is the point. Then lastly 4.2, 4.1, 4.2 there. And 720, you have 7, then one small square to represent 20. So move horizontally up to that point. So we put that mark. So those are the points that we have plotted, and therefore we need to use a ruler and draw line of best fit, line of best fit for the data. So let us draw the line of best fit, line of best fit. So the line of best fit is drawn using a transparent ruler so that it passes through as many points as possible, and the rest are evenly distributed below and above. So if I place this, it passes through the first point and the second point. You can see this is not a line of best fit because some of the other points, they are just far from there. So it should pass through as many points as possible. So let us also try another way. You can see from this case, you can pass through that point. You have this point, you have that particular point, you have the other point. So such that you can be able to draw it. At least it can pass through 3 points, and the rest should be just closer to it. So I can draw this now. So at least it has passed through 3 points, and the others are near the, the others are below the line but are closer. So but it must pass through as many points as possible. But for this case, it has passed through 3 points, and therefore we should be able to answer the question that follows. So the question says that estimate the cost of 1.5 units of water. 1.5 units of water. So number of units. So we have 1, then 1.5. So at 1.5, draw a dotted line until where it touches the line. Draw a dotted line until where it touches the line. So you can see it is touching the line, that point. Again, draw a line which is horizontal, parallel to the x-axis. So for this line, it passes halfway the small, at this point, it is halfway the small division. So that, and one small division is 20, so half of it is 10. So it will be 300 plus 10. Therefore, it means that the estimate of cost of 1 unit is approximately 310 shillings. So that is it. Thank you so much. You shall get me for the second session, which will be looking at section B or section 2 of this paper. So if you haven't subscribed, consider to subscribe, and thank you so much. See you.